Hi, now we will see about one of the technique used in supervised learning, which is called as a decision tree. So decision tree, it is a supervised learning technique which can be used for both the classification as well as the regression problems. But mostly it is used for solving the classification problem. And this decision tree, as the name says, it is like a tree structured classifier where you have nodes, okay, which represents the features of a data set, especially the nodes which we call it as an internal nodes. Those nodes represents the feature of a data set, and we have branches which represents the decision rules, and so other type of node we call it as a leaf node which represents the outcome. So in a decision tree there are two type of nodes, as I told you. One is the decision node and other one is the leaf node. So decision nodes, these are used to make any decision and have multiple branches, whereas the leaf nodes, these are the output of the decisions and they don't contain any further branches at all. So on the whole, decision tree, it is a graphical representation of getting all the possible answers to a problem based on a given condition. So we have some terminologies related to decision tree. One is the root node. So as I told you, this is a node where the decision starts actually. So it represents the entire data set, which will further divided into either one or more homogeneous set. Whereas the leaf node, these are the final output node, and the tree cannot be further extended, or it cannot be segregated further. Whereas the other terminology is splitting. So it is the process of dividing the decision node or the root node into subnodes. And the next one is branch or subtree. So a tree is formed after splitting the tree, right? After splitting the root node, you will get a subtree. So that part we call it as a branch or subtree. And pruning, so pruning, we know it is a process of removing the unwanted branches from the tree. And parent or child node, the root node of the tree, we call it as a parent node, and the remaining nodes are called as the child nodes. So a decision tree simply ask a question, and based on the answer it further splits the tree into subtrees. So here you can see I have a decision node which I am calling it as a root node. So I can based on some parameter I can go either to this decision node, or I can go to the other decision node. So what is the reason for using the decision tree? So it will mimic the human thinking ability while making a decision. And if you see the logic behind the decision tree, it can be easily understood because it is represented in a tree-like structure. So how a decision tree work? So it will make a comparison, of the value comparison of the root node values with some record, like with the data set attribute, and based on the comparison it follows the branch and jump into the next node. For the next node, again the algorithm again compares the attribute value with the other sub nodes and it move further. So it continues until the it reaches the leaf node of the tree. Let's see an example. Probably after that you can understand. So for example, there is a candidate who has a job offer and wants to decide whether he can accept the offer or not. So to solve this problem, the decision tree starts with the root node. So where the salary is considered as the first attribute, and now the root node split further into the next decision node based on the transport to the office, and one leaf node based on the corresponding label, right? Whereas the next decision node further divided based on the facility, right? Coffee facility in the office, and one leaf node. Finally, the decision node split into two leaf node, either accepted or declined offer. So here you can see, so the person is provided with some salary and he has to make a decision whether he can take the offer or decline the offer. So he is considering declining the offer as no. That will be one leaf node. So suppose if he is taking that or if he is considering that considering the offer after considering the salary as the main attribute, then now it comes to the next sub node. Now he has to think of the transport, whether the transport is more than 1 hour then he can decline it. It will be called as a leaf node here. Suppose if it is less than 1 hour, then he will come to the next part of the decision. And now he is looking for the facilities, mess facilities available there. If the mess facility is available, then he is considering the offer, or he will be declining the offer. So this is the working of the decision tree. So begin the tree with the root node, which contains a complete data set. Find the best attribute in the data set by using attribute selection measure. So at each stage you might have seen there is one keyword which will be considered for decision. Here in this case salary, here in this case transport, and here in this case the coffee facility. So that is called the attribute selection measure. Now divide this root node into subset which contains the possible values for the best attribute. Now generate the decision tree node which contains the best attribute, and recursively make a new decision tree using the subset of the data set created in step 3. So continue all these steps till until a stage is reached where you cannot further classify the nodes, and the final nodes as the leaf nodes are found. So these are the working steps of a decision tree. So what is the benefit? So it is easy to understand and interpret. They can handle both numerical and categorical data, and it handle the missing values and outliers also. Whereas some limitations are there. The first one is overfitting. So overfitting occurs in decision tree, and they are very sensitive to small changes in the data, and they can create the biased model. It suffers with the bias trade-off. So let's see what is a attribute selection measure. So attribute selection measure, we can select the best attribute for the nodes of the tree. So there are two popular techniques available in attribute selection measure. One is the information gain, and other one is the Gini index. So to know more about that, we will see what is the popular decision tree algorithm. So I have this ID3, which we call it as a iterative dichotomizer tree, which is one of the earliest and simplest decision tree algorithm. And C4.5, it is an extension of this ID3, and it can handle both discrete and continuous attributes. And CART, this is a very famous algorithm, which is the full form of CART is classification and regression tree, which can be used for both classification and regression task. So the decision tree, so main part is CART and ID3, and CART uses the Gini index, whereas ID3 uses the information gain, that is the entropy and the information gain. So let's focus on this entropy, information gain and Gini index. So what is an entropy? So it measures the randomness in the information which is being processed, or we can say it measures the purity of the split. We have to start with an impure subtree. Now we have to split it, and finally at the end you should get a pure subset. So this is called entropy. So the higher the entropy, the harder it is to draw any conclusion from that information. For example, as I told you, I have a set of nodes which is having both yes and no. So finally I have to apply this some algorithm, maybe ID3 or CART or the other one, C4.5. Finally I should end up with a pure subset where I will be having either yes or no in that format. So that is called the entropy. So in this example I have a node, right, for let's say it is A, where I have the output, totally I have 12 outputs. Out of the 12 outputs I have 7 outputs with yes, and 5 outputs with no value. So for such case I'm going to apply the entropy. So now this entropy, right, this is the formula. Entropy of S is equal to summation I is equal to 1 to C minus Pi log 2 of Pi. So where P, it talks about either S or no. So let's focus on the S alone. So P of S is equal to probability of S divided by probability of yes plus probability of no. Right. So let's apply that formula for the node B and C. Right. That is the subnodes, where B it has 2 S and 4 no, and C it has 5 S and 1 no. So if you add all the yes, it is a 7s, and add all the no, you will get 5 no's. Now I am applying the formula of entropy for node B, and finally I am ending up with 0.92. and the unit for entropy is bits, so I have to use bits as the unit here, and entropy for C, the value is 0.65 bits. So basically entropy ranges from 0 to 1, where 0 considered as the pure subtree and 1 will be the most impure subtree. And information gain, so it calculates the reduction in entropy, or it is like the transforming a data set into some other way. Basically the metrics used for measuring is the quality of a split, and it can be used for feature selection by evaluating the gain. So here I have to consider the gain of each variable in the context of the target variable. So in order to calculate this information gain, I have to use the entropy answer. So for example, this is the formula for gain. So the gain of S comma one particular node. So in our case I am considering A. So the formula is entropy of S minus summation S of V by S entropy of SV. So where is this SV or the subnodes, the subnodes which we have to consider. Okay, so in our let us see here. So the same part I have considered. So entropy of S, it is calculated. So entropy of S in our case it is root node, which is the impure data set. So there I have 7 S and 5 no's. As I told you, we have to calculate based on the S and no's. So I have S and followed by no's, and the entropy of S is 0.97 bits, and already we have calculated the entropy of B and C. So here the entropy of B with S values and no values. Okay, similarly for C also I have S values and no values. So all the three values I have got. Let us apply all the three values here. So here I have 0.97 minus what is this SV. So it is about the number of values, that is a 6 by 12 into 0.92 minus 6 by 12 into 0.65, which is equal to how I got this 6 in the sense I have to add these in B. Okay, I have 2S and 4Y, so I will be having 6. Out of the 12, I have 6 values present in B. Similarly for C also 6 values present in C. So that's why 6 divided by 12, and this is the B bits, and this value for C, and I am calculating and I found the value as 0.185. So the next one is Gini impurity. So Gini impurity, it is a measurement of checking the likelihood of an incorrect classification of a new instance of a random variable, whether if the new instance was randomly classified according to the distribution of the class label. Okay, so now I have to check the likelihood of that incorrect classification. So the formula for Gini index is 1 minus the summation of I is equal to 1 to n p square, right? Where p square, again we have to talk about probability of yes and probability of no, and squares also there. Okay, so in our case again we know that from the previous calculation entropy of C is 0.65 bits, right? So let's focus on the node C alone, right? And the number of yes here it is 5, and the number of no is 1. So let us apply this formula like a P of S and a P of no, that is 5 divided by 5 plus 1 and plus 1 divided by 1 plus 5. So finally I ended up with 0.3. So this is the value for Gini index. So entropy ranges from 0 to 1 as I told you already, whereas Gini impurity, the value ranges from 0 to 0.5. So let us see the steps involved in an ID3. So you have to calculate the entropy for the complete data set, that is the first step, and the second step for every attribute or feature in the data set, calculate the entropy, right, for all the unique values, find the average information entropy for the current attribute, and calculate the gain. Okay, and select the highest gain attribute, and so that now you will get a split. Now you will move to the subnode and repeat the process until we get the tree we desire. Okay, so this is the steps involved in ID3. So with this I will stop. Thank you.